Okay, so this is, we got about halfway through this section here, and I'll just kind of recap, just review where we've been. I was talking about slopes, and that when you have a parallel line, the slope is the same, intercepts are different, parallel lines don't intersect. And then perpendicular lines have the slopes as the negative reciprocal, and so I tried to lay it out with that triangle and see that what becomes the rise is now the run, and vice versa, and then the fact that positive slopes perpendicular line is negative. Okay, and we talked about the slope as a you can look at the slope as being the rate of change. And sometimes it's hard to tell what should be your x value and what should be your y value. Like we'll be dealing with some questions, things like, is it dollars per hour or is it hours per dollar? And so depending on which one you consider the x's and the y's, you could get essentially the inverse of one equation. So we'll talk about that a little bit more today. And then to get to the equation of lines, this is the thing that will allow you to take a slope and a point and put it into the form of a line. And it doesn't matter which point you choose when you're putting in here, so long as the x and the y correspond to each other. And on this slide I showed that the two, you get exactly the same equation by using either point. Okay, and let's see. I think you did this one in class, and we found that we had the equation y equals negative 3x plus 2. And then, did we do this one, the one with a parallel line? Yeah. Okay, so you found that basically you identify the slope, stick it into the equation, and find your equation, and check it. How about this one? Did we do the perpendicular line one as well? Okay, the other class I guess wasn't quite as far as you are, as this one. Okay, so this one basically we identify the slope of the first line, take its negative reciprocal, stick the point in the equation, get the line. Okay, and that's just a matter of graphing it. All right, so we actually went pretty far on this. We have three forms of linear equations. These are equivalent. You use them for different points, for different purposes. This one you almost never state an equation with the point-slope form. This is one that, like you did on some of the exercises, you actually get an equation out of a line by sticking in the points, and then you most frequently simplify it into the slope-intercept form. Now we're going to talk a little bit about a modified standard form. And by modified I mean we're going to stick the C on the other side of the equality sign, and we'll see that when it's in that form, oftentimes you can graph those equations very, very quickly because you just essentially assume, or what you do is you basically find both the x and the y intercepts and then draw a line between the two. Okay, so what you have to know. What you have to know is, given 2 points, can you calculate the slope of a line and determine what the line is? If you're given a line and a point, you should be able to determine the equation of a parallel line through the point and a perpendicular line through the point. So if I said, here's an equation, y equals 2x plus 1, I want a perpendicular line to go through the point 5, 3, you should be able to do that. And the same thing with, well, both parallel and perpendicular. And then the next thing you should be able to do is, given a graph, determine its equation, and given an equation, make the graph. Okay, so lines are not hard to draw. There's several different ways of doing it. It's just a matter of finding 2 points that are appropriately far apart and then sketching it out. And then the last thing is determine the slope and y-intercept of a linear equation and write the equation of a vertical and horizontal line. Okay, so remember that a vertical line is where you have just x equals a number. So when x equals 2, you have a vertical line. When you have a horizontal line, if you think about the equation as y equals mx plus b, horizontal line has no slope, so m is 0, so you just have y equals some constant, which is the intercept. So it'll be something like y equals 3. So this should be second nature to you. As you get to calculus, you're going to be doing this for a lot of different kinds of operations. You're going to be doing things like making linear estimates of functions that don't necessarily compute very easily, but you make a line and you can compute the points, things of that sort. So this is really kind of a basic toolkit that you should have. I know that's a lot of words up there. I'll give you a couple minutes to finish it out. And so finally, let's look at an application of this.
Wait, what was the last one? The last one?
Write the equation of a vertical and horizontal line. Okay? Okay, so let's look at an application here. Bill rented a car, drove 200 miles and paid $95. Katie rented a car, drove 150 miles and paid $85. Okay, the rental company charges a daily rate plus a per mile rate. What was the rate structure? Whoops, now I'm showing you how to do it. Don't want to do that. Okay, so what I want you to do here is solve this problem and keep in mind the steps that I would like to see you do on every word problem. And I want to particularly pay attention to how you would answer the rate structure question. So here, if you have a per mile rate and a daily rate, that kind of infers that you have a linear equation going on. How do you get that? What's the x? What's the y? All that sort of thing. So I'll let you work on this for a little bit, and then we'll see how you do. So that'll be posted sometime mid-afternoon today. Okay, any questions on this? So we're going to move away from linear equalities between equations involving two variables in a linear relationship like a line, and we're going to move off now to inequalities. Okay, so linear inequalities come up pretty regularly, right? If you're looking at a diet problem or something like that, you want to say, okay, I want to eat a combination of foods that will give me more than a certain amount of vitamin A. Or you want to eat a certain combination of foods that will give you less than a certain amount of fat. And so things like, a lot of problems naturally form themselves into inequalities, where there's not just one answer, but now you have very large sets of answers, just like when we had the inequalities with one variable, we would have a set. We also have an infinite number of solutions to linear inequalities. Okay, so these come in the form of equations involving x and y, and a, b, and c in this case. In these cases are all constants. Now notice the form of this is slightly different than what we had with the y equals mx plus b kind of form. I'm putting both the x and the y on one side and then the constant on the other. So it's kind of a modified standard form because I put that constant on the other side. But a form like this oftentimes falls more naturally out of the problems that you're working on. And also we'll find that graphing these kinds of inequalities, or even if you make them equations, they graph pretty readily. So we'll be looking at that as well. Okay, so a solution to any of these things is an ordered pair. So for example, if we have the inequality 3x minus 2y, you know, we can, and I'm just choosing this point arbitrarily, these 2 points. If I have 1 comma 3, that works, that's true. 3 times 1 minus 2 times 3 is negative 3 is less than 4. If I choose another point, that's not necessarily on the line, but it's just some other point, I'm also getting something to be true. So there's many, many different values, many different ordered pairs that can make this work. Not just a particular y for any particular x like we had in the equalities. Okay, so many solutions here. Okay, so let's look at what happens with a graph now. If we have this equation of y equals 2x plus 1, hopefully you can all graph this pretty readily. We have an intercept of 1, and then we have a slope of 2, so we can count that off. Or we can just choose another point. You know, if we say x equals 3, then we know y equals 7 or something like that. So what I said earlier is reinforced here. Where you have one particular x, if you choose an x, there is exactly one y that corresponds to the solution. If we were to look at the inequality now, okay, we still have this same line, but any point where x equals 1 along here, below this line, make it true. So, you know, for any number of different y's that I choose, this is all true. So in essence, what we want is this whole region, this whole area that's to the right and below the line is going to be our solution. So the way we're going to do that is we're going to be shading the solutions. So let's say now we have, we want to make a graph of one of these things. So the first thing that we have to notice is that when we're using a strict inequality, so if it's less than or greater than but not equal to in either of those cases, we're going to indicate that with a line, or excuse me, a dashed line. And then if it's the greater than or equal to or less than or equal to, we're going to indicate that with a solid line. And I'll explain a little bit more why we do that in a little bit. So let's say we have this equation here. This y is less than 2x plus 1. Now, the thing that we want to do is we want to graph the line, and we're going to graph it with a solid line. Now, the reason why we use the solid line is because the equality y equals 2x plus 1 is part of the solution, so we'll indicate the line as part of the solution. If I put a dashed line, all that means is that's the boundary of a solution, because what makes that, you know, equal is not going to be part of the solution if we only have the inequality without the equal sign. Okay, so then what we're going to do is we're going to take a test point, and we can choose any point, because what happens here is that the solution is either going to be everything on this side of the line, or it's going to be everything on this side of the line. So you only need to test one point. Don't test a point on the line. That just tells you that the line is in the right spot. 0, 0 is often the easiest point you could use, because, of course, 0, 0 in a linear equation is an easy computation to make. So what you do is you stick the 0, 0 in the equation, and we find that 0 is less than 1, that's true. And so if it's true, then we shade that side of the line. So if my test point is 0, 0, which is on this side of the line, and I plug 0 into my equation and it's true, this whole side then is going to be the side that's the solution. So there we have infinitely many points. We have half the plane is part of the solution. Now, if we test 0, 0 and we end up with something false, like let's say if this came out to be 1 is less than 0 or something like that, then what we would do is we would say, okay, 0, 0 is not part of the solution. We're going to then shade the other side. All right, so let me give you another example here. So let's say I want to sketch this graph, and I'm going to have this in that form where both the x and the y are on the same side. Okay, so I'm going to draw my scale, label everything, x and y, label my scales. And so since this is an inequality here, without the equals part of it, I want to graph it as a line, but with a dashed line. Okay, so now I'm going to find the intercepts of this thing and plot those points. So the nice part about writing an equation like this, and perhaps it's easier to write it on the board, x plus 2y is equal to 2. To plot this line, what I can do is just imagine x to be 0, so x drops out. So you can do that in your head. What does y equal? Equals 1. So I have the point 0, 1. Then I think, okay, if y is 0, then x is 2. And so there's my second point. So really just by looking at the equation and doing a little calculation in my head, I have these 2 points that I can put on my graph. And I'll go ahead and do that. And then 2 points make a line. I'm going to make a dashed line, so I go ahead and draw that. So I'm good there. So I don't know if you've ever used this method of graphing a line, but it's really quite convenient. And there's only one circumstance that it doesn't work, and that's when some combination of x and y equals 0. So in other words, you have a line that goes through the origin. We have to do something different for that one. Okay, so next step is we want to test 0, 0. And so we put 0 plus 2 times 0 is greater than 0. It's false. So I found that the origin, 0, 0, is false. So the other side gets shaded. Now on the previous slide I used, a big wide marker and I got it all colored and everything like that. That's not really practical with a pencil. It makes it look like you're crossing the whole thing out. So drawing just lines through it like this is a perfectly good way to shade these graphs. Okay, it's not quite as messy as coloring the whole thing in. I mean, if you want to take a little highlighting marker and color it in, that's fine, but it's generally not necessary. All right, everybody follow okay? Yes?
I was just wondering if we can family.
Yeah. How's that? I guess it's going to rain tomorrow, huh? Did you hear that?
Hooray!
That's the good news. The bad news is it's going to be very little. They say less than 5/100ths of an inch, which is just enough to mess up your car.
Is that considered rain?
What's that?
Is that considered rain?
Well, it's heavier than fog, right? Okay, so here are several that I would like you to try. And actually, I have 4 of them here. So with these 4, I'd like you to work on these, and I'm going to ask a few of you to come up and draw your graphs. Okay, so the last thing I want to do is, let's see here, work on a word problem, and this shows you, it's problem 50. It shows you what kind of problems you generally encounter that you use inequalities for. And one of the things about these inequalities is that when you get two of them, you get something that you have, let's say, a single best point. Okay, and we'll talk about that once we're going through here. But okay, so let's say you have two part-time jobs. One in a candy store pays $8 an hour, and the other is providing childcare, which pays $11 an hour. Between the two jobs, you want to earn at least $160 per week. Write a linear inequality that represents the different numbers of hours you can work at each job, and graph the inequality and identify three ordered pairs that are solutions to the inequality. Okay, so I want to go back to that format of solving problems. So the first thing that we're going to do is you're going to take the fact that you have two part-time jobs. The candy store is $8 an hour, and the child care is $11 an hour. And so you want to, between the two jobs, you want to earn at least 160 hours per week. So we have two independent variables here. One of them is the number of hours that you work in the candy store, and one of them is the number of hours that you work in the child care. So the very first thing you do after you write down your information is you define your variables, and we'll say X is the number of hours in the candy store, and we'll say Y then is the number of hours in child care. And so we want, between the two of these jobs, we want to earn at least $160 per week. Okay, so how much are we going to earn at the candy store? So that's going to be 8X. All right, how much we're going to earn in child care? That's going to be 11Y. And we want that to be more than $160, or it says at least $160. So what's the appropriate sign here? I know I'm going to have 160 over here. What's the appropriate inequality sign here? Greater than or equal to. Okay, so you want it bigger than. The equal to means at least, so you can have the least value is when they're equal to each other, and then you have this. So when you take this, then you, so this is a linear inequality. So we got what A is talking about. Now B is graphing it and identify three ordered pairs. Now I think we've probably done enough of these in class to see, you know, you're going to have 2 points when Y equals 0, X, and I won't make this to scale, is going to be 160 over 8, which is 20. So we're going to have 1 point here. And then we're going to take Y equals 160 over 11, which is what, about 15? 15 times 11 is 165. So we'll say it's about 15. And then we draw our line. And then this is our, this is our region out here, because we want it to be more than 160. There's one other requirement that we have, or if we wanted to be really, really persnickety about this, you're not going to ever work negative hours, right? That means you're going to end up paying your employer, and that just, you know, that doesn't happen. So we actually have three inequalities. One that says what the basic math is. The other one says that X and Y are always positive. I mean, it's possible not to work that week in the candy store. That would be 0, so it's okay that X equals 0. But Other than that, it has to be more than that. So when we graph it, we actually get a region that looks like this. Okay? This is the beginnings of something called linear programming, which is a way to optimize certain things. Like, for instance, if, let's say you're looking at it from the employer's standpoint, you say, I want to make sure that the sum of these two things is less than 160, and so your, what they call the feasible region is this triangle. It turns out that the best combinations of things, no matter how many lines you have, is that either the maximum or minimums are always on the corners. You have some really remarkable properties about this. But anyway, you'll have a couple word problems on the homework as well. And so I guess this is something different here. Okay, so that's what I got. Wait a minute, we still have 10 minutes. We can do that last one then. Sorry. There's another false start. Okay, so we have 3 points. Find the equation of a line containing A and B, and then find the equation of a line parallel to AB and through C. And then of course this next one is going to be of a line perpendicular. Okay, so one last exercise to do to close off the parallel and perpendicular question.